So we're right back in here. We're going to talk more about the electrons today. We're going to talk more about the electricity. We're going to cover a lot today. This is like part 2. See, and this is part of the problem. These people don't have no clean energy. They've been on this snake oil for too long. But every day I wake up, I take a big swig of snake urine. See, that's the secret. That's why I'm in such good health. So you got to have HHO gas. That's the secret. If you want to live a long time, you want to be in good health, you need this stuff. So we're right back in here. We're going to cover some more. We're going to talk about how a lot of people are just throwing these drills out. They're throwing them in the garbage. Neighbor threw this thing out. I took it right out of the garbage. Look at this. And I got an endless amount of electricity right here. I slapped it together with the microwave fan motor. Look at this. So easy. It's all about resistance. Think about that. So we got to get them off this snake oil. So we're going to talk more about the microwave and some of the parts inside this thing. Now we've looked at the AC motor. We're going to take another look at that. 21 volts AC. That's pretty good. It's coming out of there. 60 hertz at 3 watts. It's a lot of power if you know how to use it. And we're going to take a look at some of this stuff. We're going to talk about everything. We're going to talk about the water molecule. We're going to talk about sine wave and square wave right now. We're going to go back to square wave. Here we go. And what I've done is taken this drill. So like I said, I get a lot of this stuff right out of the garbage. Think about that. These people are throwing this stuff out. So I got my drill right here. And you can see I just slapped this together as pretty much as quick as I could. And it's very solid. It's very stable. See, it's about mounting things. You always got to have a mount for these motors. Getting them mounted is half the problem. And then getting them together and getting them straight. You can see I just welded these together with some JB Quick over here. And I'll show you what we can do with that. And let's cover this so you got something to go back and read. So let there be light. So I'll give you something to read. You can pause that, go back and look. It's all very important stuff. You know, we live on an electrical planet. Think of that. It's very important. We'll talk about a lot of these things. We're going to talk about the pulse width modulator, how you can control these motors. We're going to talk about making HHO using this, the photon energy. We're going to talk about a lot of things. I'm up late at night. You guys got me up late doing this stuff. See, I don't want these sheeple to lose the game, you know. So this is what I've done here. Look, this is a straight shot. Look, you can just plug it right in the wall. Here we go. Let me turn on my voltage meter. Alright. See, I got my LED there. And see, you know what's great about LEDs? They take very little power. Look at this. 9 volt. It lights up this whole room. I'm doing that with a 9 volt battery. So eventually there won't be any batteries at all. You'll just have hydrogen tanks. Everything will run on gas, and then you'll use the gas to make the electricity by spinning the motors. But for now, I just want to talk about this. Here's 4 volts for you. I mean, it's incredibly, you know, it's putting these non-renewables in the spotlight here. I mean, they've polluted everything, and people are starting to ask questions. Where's all the power? You know, where's all the energy? Well, it's in the water. So we're going to cover this stuff. Like I said, I'll talk about. Let me plug this in and I'll show you. Let me show you. This is a straight shot. Sometimes you got to turn it to get it going. So it's already set. See, I have the LED hooked up here to indicate that power is coming in. So it's a constant supply of energy. Okay. The reason I'm showing you guys this stuff is because I think it's very important, because there's so many of these things thrown out every day. It's an endless supply of electricity. You can make these little power plants. You can spin them yourself. You can get some hamsters or whatever. I mean, you can spin these motors using a crank. You can get real creative. You can use gravity, wind. See, a lot of people, you know, they love these little motors that they get out of the microwave, but they can't figure out what to do with it. And they're like, how do I make power? Well, it's an AC motor. This thing uses an AC current out of the wall to create an electromagnetic field to spin the motor, you know? And you can't really make no DC power like you see here. But if you take the drill motor, which is a DC motor, and then just hook it up to this thing, and now you have a power plant. See, I got DC power coming out there. And that's what it's all about. So as soon as you see these things, you got to start thinking round. You know, you got to start thinking, okay, I got to get this thing spinning. So it takes very little electrical power to power this LED lamp that I have here. That's my lantern. That's my limelight over there. But you can see I can use this for many different applications. These are my scientific thermometers back here. Check it out. I usually don't make a video until I got 2 balls floating, you know. I like to see it up there, so I know it ain't too hot in here. And to make the DC power, you can use something a lot more powerful, like this Dremel tool here. Now the AC fan only puts out so much power, you know. It's low powered, but you can still use that. It's very handy. I've taken many of these apart. So we've got the DC motor here, and I'm going to hit that with the Dremel tool to show you that thing can put out 18 volts at 10 amps. It's ridiculously powerful. Watch. So did you see that? Puts out a ridiculous amount of electricity. And that's just in your average hand drill. And now they make them with even higher voltages that put out even more amps. Get these right out of the garbage. You can just use the AC fan to power it too if you want and get some low voltage. Or you can go high voltage with something a lot more powerful. An endless amount of DC power. Not even a tenth of an amp. Look at that. So it pulls very little electrical power, and that's great when you're generating these small sources, because you can get a lot more for your money. Think about that. It's a lot more electrical power, and you can have these PWMs to control motors that spin other motors. You save money. Think about that. And it's good to have these inverters too. If you have batteries, like I'm trying to get away from batteries completely. I'm going to have pure hydrogen. So you're going to have just tanks of hydrogen and regulators and things like that. And there's no oxygen. There's no oxygen in a separation system, and that's next. Right now I'm just working on some of my smaller electronics, and I wanted to make this quick video. So we'll go over this section real quick about diodes. Go back and read that. It's very simple how a diode functions. You know, LEDs are important, very powerful. So if you take a look here, this is one of the secrets when you look at the back of some of these electronics. See, it tells you right there on this household automatic battery charger, the input is 120 volts AC. So you have the house current, and it converts it into a DC. You know, the output is 12 volts at 750 milliamps. See, it's usually to charge batteries and things. It's very low voltage, you know. It's like a dripping faucet. Think about it, you know. Things are charged very slowly. You know, it doesn't happen real fast. It's not like this. You don't charge batteries. You know, even with solar panels, think about that. So I'm going to try to cover as much as I can in these next few videos. We're going to talk more about electricity. And it's all about resistance too. Think about it. Every electrical circuit has resistance. Every wire, every motor, there's some resistance there. And you want to limit that resistance. You want to use the correct size wires. You want to have good connections. Let's turn this thing on again. Let's turn it on full speed. Let's see what we'll do. Oh, I gotta plug it in. It's good to have the kilowatt because it tells you exactly what you're using in electrical power. Okay. We'll take it up to a much faster speed. See where we at? We're at 6 volts. Okay, see, it's good to get that AC current coming in too. It's not all about DC. Speed it up here. Oh yeah, that thing's really going now. Let's see if we can get 12 volts out of it. Yeah, there you go. See, so you got 12 volts coming in AC now. AC power. And if I wanted to, I could wire up a little transformer. I could make a little transformer and step the voltage up just about as high as I want. But you lose amperage. See, the power doesn't come from nowhere when you make a transformer.